Hi there, everybody. Welcome in. We're glad to have you here at the Pilvi Theater. We're going to welcome our next guest to the stage. He is from Cylance, so please welcome Thomas Pernicchiaro.
Thank you, everybody. Thank you for being here. I'm excited to kind of show you guys what we have here. We just want to breeze through some of these slides here real quick because we got two demos we want to show you, and we only have 20 minutes. So here's kind of the agenda I've laid out. So basically just traditional security layers. Talk a little bit about the past, why data science in those traditional security layers, what it's doing for it. A little bit about what is data science subcomponents, why data science for security, and then the benefits of applying it. And I can show you guys in a demo what we got for you guys. Can I get a show of hands? Who's heard of Cylance before? Nice, perfect. So you guys may not have realized, but the whole security industry is pretty much using data science in their existing products, new offerings. Let's see here. Yeah, so the entire security is moving towards using data science for the new products and offerings. Just a real quick explanation of what is data science and put it in kind of a security context. It's a set of algorithmic tools that allow us to understand and make automated decisions using statistics, mathematics, and statistical data visualizations. In a security context, it allows algorithms to kind of go to work, data mine, train data sets, use those algorithms to now find malware, run through big terabytes and petabytes of logs from network firewalls to network routers, and make assumptions on whether they're threats or not or benign behavior. So really, on the subcomponents here, these are pretty long explanations. Just kind of want to shorten it up again and putting it in a little security context here. So machine learning is really in the security context is about training big data sets to create an algorithm to go and now data mine and look for malicious behavior and intent. The data mining, just like I previously described there, is the algorithm that's outputted from training those machine learning algorithms and go to work on all those things from your firewalls, your routers, and then the data visualization part is a statistical graphical representation of that. So looking at a big swath of data and sort of putting together commonalities and why those logs are common. So the traditional security layers, antivirus, this is basically where we're using data science today at Cylance, using algorithm deployed on endpoints to detect malware. So when we train our data sets, what that does is spit out an algorithm that sits on the endpoint, and we're able to detect malware in a short 100 milliseconds of time frame there. So it's all static pre-execution. We don't need to let the file run to know it's bad. And for the firewalls, really it's about using those algorithms to sift through all that data that everything's collecting into your SIEM. So you've got firewalls, you've got them, the network edge is not really the same anymore. It's kind of sporadically pushed all over the place. You've got infrastructure in clouds, you've got on-prem infrastructure. Everything is kind of reporting back into a centralized location. So that can sometimes, terabytes, petabytes of data. A single human wouldn't be able to kind of run through that data and give any intent, whether that was malicious or benign. As far as the SIEM, that's where a lot of the user desktops, servers, applications are all pushing their logs over to a centralized location, and again, able to detect malicious behavior based on some of the patterns that they've seen before. So why data science for security? So security is all about the data. If you really look at it, there is just too much data out there. There's over 700 unique malicious executables out there right now. And any one of them could be the new Stuxnet or the new WannaCry, but there's not enough time and research and money put into reversing that malware. So the landscape keeps growing every day. For a human to go through that is almost impossible. As well as the attacks are getting a little bit more sophisticated. So looking at those patterns are going to help you detect and do a little bit more smart threat hunting. So here's the benefits of applying data science to next-gen AV that we've sought. We call it threat predictive advantage, to where we were able to actually stay out in front of some of these attacks. So Emotet, we went back after we found the first payload and went back and tested it against some of our older models. So Emotet was 18 months we were able to predict it able to get out there and predict it. GoldenEye was 21 months, and WannaCry was 23 months. All Cylance customers that had Cylance deployed didn't get hit by any one of these. Here's a list of supported operating systems we have. The one thing I didn't put on the edits here is the Amazon Linux is not due out until December, but everything else you guys see on here is out currently. So let me kick that demo off, kind of show you guys the predictive advantage of it in action. Perfect, you guys can see. So I just want to give you guys a little background of what this first demo is. So this is a demo environment. We've got this PC hosted out in our cloud. What we do here in this environment is we've got malware samples that come in from VirusTotal every day. Can I get a show of hands? Anybody know what VirusTotal is in here? Okay, cool. So I'll just give a little brief description. So it's owned by Google. It's probably the biggest collection malware repository in the world. And basically all the antivirus engines are in there, and they give detection. Some of the products just do lookups to go out to VirusTotal to get a pass or fail. They use that as part of their prevention suite, where we're completely local. We have that algorithm on the box. So right here, this PC, this machine model is from 2015, and some of these samples that have come in here today have gotten repacked and encrypted. And what that is basically these samples were taken off VirusTotal, and the hashes, everybody already knows about them. So what we do is kind of obfuscate those patterns, change the hashes a bit, change a little bit of the behavior on those malware samples. So we're able to make it all 0-day. This is stuff no one's seen before. We haven't seen it before, and none of the engines in VirusTotal have seen it before either. So before I pop these over here, I'm going to put 4 over here. And we might not catch them all. Like I said, these are all new. We packed them. We obfuscated them. So this is stuff that a regular hacker is going to do to these files. So right there, we pick this one up. And I'll give you a little bit background on Protect, our product. So we've got 3 features in there that have our data science algorithm going to work on these pieces of malware. So we've got what we call background threat detection scanning. And we've got execution control and file watcher. So we don't scan because we're not a traditional AV. We don't update signatures all the time. We have that local model on there. As you guys can see, this is from 2015. And it could have actually sat out there and not been on the internet for this amount of time. And if you ask anybody if they would not, update their virus scanner on their desktop for, 3 or 4 years, they tell you you were crazy. So a little bit about this. That was the file watcher that caught those. So I just want to throw a couple more over here and let you guys see, because we don't put anything in a sandbox. We don't take any of these files and push them up to a cloud and blow them up to see if they're bad. We're actually all static pre-execution. None of this stuff is actually running. So as I click on these files, we're stopping them. We're actually going to auto-quarantine them. And that's pretty much it. That's what the user sees. We can be completely silent to the user. We don't have to have this little UI on the desktop. It can be completely silent. So your user, basically the only thing they're going to see is these files just keep dropping off their desktop or their documents or wherever they're at. So I'm going to get into this other demo. See here. And this is simulating a user's mailbox. And just to kind of show you guys what we do in this demo environment is every day we send weaponized documents, and we use names of our employees, and this is how we conduct phishing schemes too for training practices. But this all looks real, and this is a lot of what your users are looking at and faced with today. This stuff just comes across. It's using your employees' names that work there. It looks real. So just kind of show you right here. So this is a document. This is weaponized. This would enable a C2 server to kind of exfiltrate data back out to a centralized location for the attacker. So you can see here where our optics notification popped up. Again, this could be completely silent to the user. You can configure this custom, let them know, call the SOC, call IT. You can lock the PC based on, if there was 3 or 4 attempts, maybe you just want to completely lock the PC down, tell them to go to the IT department, you can do that. I want to show you one other thing, and this is kind of where the analysts are going to live in. So your security analyst, or maybe you guys don't have any, it's the network guy that's actually running the security team. This is kind of what he's going to be faced with. He's either going to be pushing this stuff to a SIM, if he's lucky enough to have one, or he's going to be completely in this console working and looking at these detections and seeing who's trying to come in, what type of attack it is, and how to block against it for future purposes. So what we can do here is, I'll show you guys the focus data, and this is basically the root cause analysis. So when that script popped off, you're going to be able to tell, was the user in Outlook, was he in Internet Explorer, was he in Chrome, and then a process started to open up PowerShell scripts. You get all that information here. So that wasn't, let me see real quick. Yep, there we go. So these are the artifacts. So I'll start off first on the detection. So this is the detection that popped up. This is the artifact that pops up. You've got everything from the artifacts of interest to what processes tried to spawn off with that weaponized document. We can go in here and see which user it was, the hash of it, the thumbprint. What else I can do right here is request the process focus. So this is going to tell me what was going on, that root cause analysis I was talking about earlier. So if you look at this here, this is how malware is trying to obfuscate and hide itself. It literally is really tricky to kind of catch this stuff, to where these are all the events that happened leading up to, if I pull this all the way over here, so there's about 160 events, and really the only ones we're worried about is where this red shield popped in. This is where our algorithm came in, blocked that file. But all these events previously is how the malware tried to actually hide itself into, tricking itself in the actual endpoint solution into thinking it wasn't malware and it was something benign. So what we've got down here now for the tools for your analyst is now we can take these artifacts and search throughout the rest of the environment. So I've got this file name now, and what I can do here is actually go through my environment and run this query, and this is going to tell me exactly how many devices and who has that file on their desktop, maybe ready to execute. Maybe it's just sitting around. Maybe it's actually someone didn't detonate it off, and it would try to move laterally within the environment. But what we can do here now, once these results come back, we can actually lock these PCs down. We can make it to where they can only talk to the Cylance console and knock it out anywhere else, or we can completely lock them down and send them over to the IT group. One other thing I kind of wanted to just show you guys here on the packages. So we have this feature called the playbook results. So based on these detections, what you can start to do is get into an automated threat hunt mode, to where you can actually get these detections popping up and put some type of automated response into it, to where you actually have an analyst in a box, pretty much. So based on that Office DDD script interpreter detection, I can go out. I can actually go do a memory dump on that person's PC, program execution records, pull that stuff back to see if he's been owned or maybe someone's been exfiltrating data in there for a while. I can get all that information back. So kind of that's pretty much all I had here today. So really, our demo here with our old 2015 model kind of just shows you how when you train those data sets and you get large data sets and unique data sets and you put them in your training models, this algorithm from 2015 is still going to work on new threats. And every year we put out a new model every year, and it just keeps getting better and better and better. So with that, just kind of end it there. Does anybody have any questions?
And if you do, I'd happily bring you the microphone so everybody can hear the questions. Just raise your hand. Anybody?
We also have our booth over at 1036 where we have meeting space where we can do live attack demos. This was kind of just a little taste of what we can do just with the limited time. And that's pretty much it.
All right, I think we have one question over here.
Hi, thanks. So we showed like the graph of the malware trying to hide itself and Chrome was doing something. So like what kinds of behaviors are you looking at? Is it like system calls or networking? I mean, what are the things that you're looking at those little lines represented?
No, that's a great question. So in that particular scenario, we weren't looking at anything behavior-wise. We were actually, the script in there ran, and then as soon as that malware hit the disk, that's when our execution control, file watcher, or background detection scan came into play and picked up that file. Yeah, so we really don't want to, because if you think about it from the old EDR tool sets, all those would have been incidents. They would have been events that happened that an analyst would have rolled on. So really, when you look at it, we kind of give it right to you. Hey, all these events happened, but this malware dropped on disk. We stopped it. Here's the artifacts from that attack, so you can go out there, create rules, create some, maybe even put a firewall rule in if it was going out to talking to somebody to go prevent them next time.
Anybody else? Questions? Going once, going twice? All right, I think we're good.
Go.
All right, thanks everybody. And thank you, Thomas.
Thanks.
And again, their booth is 1036 if you'd like to visit them there.